Hey guys, welcome back. This is Professor Rodan again with topics in mathematics. And this video is going to talk about 8.2. There are 4 worksheets in 8.2. We're going to try to get through all of them quickly. And so they include worksheet 3, worksheet 4, worksheet 5, and worksheet 6. All right, so let's get started with worksheet 3. Okay, so first of all, this is about polygons, okay? And so basically, we're just going to fill in these definitions. Just a few of them are a little bit longer than the rest. But polygons basically, a closed figure with at least 3 sides. Okay, so the minimum would be to be able to close a figure would be 3 sides, like a triangle. Okay. If it's not completely enclosed, it's not a polygon. And then we have the word regular. We see this a lot. That's all sides have the same length. Okay, so they have the same length and equal angle measures, the inside angles. Okay, so for example, a triangle, if all 3 sides of the triangle have the same length or equal, it's called equilateral, and they also have the same equal angle measures, equal angular. Okay, so that would be 60, 60, 60, 80, 180 divided by 3. So this is just a few examples. So let's talk about one vertex or various vertices. These are basically where two sides meet, which create angles. Okay, so let's take a look at the triangle. So if I made this a regular triangle, then this marking means that they're all the same length. Even though they may not look it, the marking suggests that they do in fact have the same length. Okay, so, and then these all have, this marking means that the angles have the same measure as well. Okay, and this has a specific name called equilateral. Okay, or equal angular as well. And these are the vertices right here. Okay, so now a polygon with 3 sides has a specific name. We already know that is a triangle. Oops. So it comes from the word tri. Quad suggests 4 sides. Okay. Penta suggests 5 sides. Hexa, 6 sides. Heptagon, 7 sides. Octagon, 8 sides. Decagon, 10 sides. Dodecagon is 12 sides. Okay, and we actually skipped, for some reason, the nonagon is not here, which is 9 sides, and that'll go basically right in there. All right, you can look at all these and the pictures of these. If you go to table 8.2 on page, okay, so it's on page 447, and it's actually called table 8.1. Okay, so you can take a look at that. All right, now let's talk about triangles specifically. So triangles, there's various types of triangles, and the first one's acute. This is where all three angles are acute. Okay, so an example, so you know that's less than 90, greater than 0. So an example would be 50, 60, and 70. Next we have obtuse. This means that one angle is obtuse, which is greater than 90 but less than 180. An example would be 100, that's obtuse, and then 20 and 60, those are acute, but at least one is obtuse. All three of those are acute. Right one angle is right, or you know that's 90 degrees, so 90, 45, 45 as an example. Now those have to do with the angles. Okay, so then the next set have to do with the sides. So scalene is no two sides are equal, which means that all are different lengths. Okay, so no two sides. Isosceles is actually having exactly two sides equal, and that also gives two equal angles as well. And then the one I already mentioned is equilateral. So all three sides are equal. Which also creates three equal angles. Okay, and so remember, 180 degree total divided by 3, 60 degrees each angle. Okay, all right. Let's go to the next page to apply some of this. I'm sorry, to go over quadrilaterals. Okay, next page is going over quadrilaterals. Okay, so quad, remember that means four sides. So parallelogram, parallelogram is specifically a polygon with four sides, but it has a couple characteristics, and that is opposite sides, are parallel. Okay. And opposite sides are equal. Okay. So that will look like this. Okay, so parallel. These are parallel. These are parallel. And the sides, these are equal. And so are these here. Okay. All right. Let's go to the next one. Rectangle has opposite sides. Parallel. Opposite sides are equal. So this meets the requirements of a parallelogram. However, one specifically to the rectangle is all angles are right angles. Okay. Okay, so we know we have parallel lines, so I'm not going to mark that again. But we do have, again, opposite sides are equal, and all angles are right angles. Okay. Next we have the rhombus. Opposite sides are parallel. And opposite sides are equal. I'm sorry. All sides are equal. Okay, typically this is distinguished from the square as more of having different angles there. Okay, all sides are equal. Alright, so if we straighten that out and make it 90 degrees, now we have a square. So basically this is going to be the same thing, except the angles are going to be right angles. So same thing as the rhombus. And then the additional one would be all angles are right. Okay. So we push this rhombus till it's now straight, so that we have 90-degree angles here and all sides equal. Okay, last but not least, we have our trapezoid. And the only characteristic is that only two sides are parallel. Okay. So there's various ways to draw this. The typical one has the top side shorter than the bottom side, but they are parallel. Okay. Or I can draw one of the angles, two of the angles to be right angles, and still you have a trapezoid. Okay, so those are the quadrilaterals. Now let's go to page 3 to start applying these. Okay, so it says, describe the figures below by selecting as many names as possible from quadrilateral, parallelogram, rectangle, rhombus, square, trapezoid, or none of the above. All right. So what I'm going to do, so in the video, I'm going to do straight down this column here, and then this one you're going to do in class. Okay. So the first one, this meets the requirement of a quadrilateral. So I'm going to put a Q for quadrilateral. This also meets the requirement of a parallelogram. And this is also a rectangle. Okay, which I'm going to abbreviate with RE. Okay, so we know this one's a square. But we also know that this could be a rhombus. This meets the conditions of a rhombus. Okay, even though it's not tilted, it's still a rhombus. But the normal rhombus is tilted and the angles are all different. Or they have two pairs of angles that are different. So this also meets the condition of a parallelogram and a quadrilateral because it has 4 sides. Okay. Next we have, well, it almost looks like a rhombus, but the sides are not all equal. So this is just a plain old parallelogram. And of course it has 4 sides, so it's a quadrilateral. G, well, doesn't even have 4 sides, so that disqualifies it from everything else. So this one's none of the above. And then I surely looks like a trapezoid. And could it be anything else? Well, it does have 4 sides, so definitely a quadrilateral. Okay. All right. Let's go to the next page. Take a look here, and these are multiple choice exercises. Basically, you want to figure out what's going on here. So I'm going to do the odds as typical. So it says select the geometric figure that can possess all of the following properties. So let's see, something that has 4 sides, opposite angles are equal, and the diagonals are not equal. So opposite angles are equal. The diagonals are not equal. So this is not the same as that. Well, for a rectangle, that looks the same. So for the diagonals not to be equal, we have to push it on its side. So it kind of looks like this. So So now the diagonals are not equal. There's further distance between one and the other. So this would fit the parallelogram. Okay. Okay. And number 5. Let's see here. Well, that definitely looks like a trapezoid because these look parallel. Okay. And they have 4 sides. So definitely not a rhombus. On a rectangle. These are not parallel, these 2 right here, so it's not this one. So it's 5. Trapezoid. Okay, great. This is worksheet number 3. That's the first worksheet in 8.2. Let's go to the second one. So this is just classifying quadrilaterals. So it says sort the quadrilaterals into groups according to the following properties. Figures may be placed into more than one group. Indicate the letters of the quadrilaterals that have each property. This is going to be hard to do in the video since the answer key is on the next page. Okay, so I'm just going to look at a few of them, okay? So, all sides are congruent. Well, we know that's a square and a rhombus. And if you look at the next page, that would be that looks like a rhombus. This one looks like a square, looks like a rhombus, another square, and another rhombus right there. Okay, so that would be A, B, E, L, and M. Okay. The next one says at least one pair of sides are parallel. Well, that's going to be pretty much all of them, except for, let's see which ones don't meet that criteria. At least one pair of sides. I mean, that's even for the trapezoid. But this wouldn't do it. This one wouldn't do it. Neither would this one, okay? This is more of a kite. So I would just put all except those 3. Okay. All right, so you can do the rest on your own, and you can check your answer in the answer key. Okay, so let's move on to worksheet number 5. All right, the next 2 worksheets, 5 and 6, we're going to be doing a little bit more math, even though it's geometry. So this section, we're going to go over some formulas for polygons, okay? So starting at the top here, we have basically some theorems that can be proved, but we're just going to enjoy the benefits of these theorems. For example, the first one is called the polygon angle sum theorem. So the sum of the measure of the interior angles, so all the angles in the inside of any polygon, is going to be equal to the number, whoops, let me not use that. So the number of sides, depends on how many number of sides it has, Okay, you're going to subtract 2 from that. After you subtract 2, then you're going to multiply by 180 degrees, which if we just use the n of the number of sides, we can simplify this to n minus 2 times 180. Okay? Number of sides is the same as n. Okay. So, I'm going to prove this with the triangle because that's what we've worked with so far. And it doesn't matter which one we use. Let me just use the equilateral. Okay, it's got 3 sides. So 3 minus 2 times 180. So 3 minus 2 is 1. 1 times 180 is 180. Okay? So if you ever wondered why it happens to be 180, well, it can be proven by this theorem. Okay? So you don't even have to worry about that. So 180, we already knew that, but now we're proving it with this formula. Now, I also told you that the interior angles was 60. And that is going to happen through, basically this is called the corollary to the polygon on angle sum theory, but it's the measure of one interior angle, okay, of a regular polygon. So basically it's the sum of all the angles divided by n. That's it. That's the formula. Okay? But you can also replace that sum with the n minus 2. Okay? So as long as you get the sum, just divide it by n. So once again, I already showed this on the other page, but basically, if we know that a triangle has 180 degrees, and it's a regular triangle, and you divide it by 3, because we know the sum is 180 divided by 3, then that's going to be 60. Okay, which we already knew. Okay, this works for any regular polygon. Okay, the last theorem, and we get the benefits of the formula, is the measure of an exterior angle of a regular polygon. So what we mean by exterior angle is we're talking about, let's say this one right here. So we know this is 60, 60, 60. So what is this exterior angle out here? Well, that's easy. That's 180 minus 60 is 120. Okay? But if you don't know the interior angle, you can just use this formula. Okay? It's 360 divided by n. Okay? It's that simple. 360 divided by n, and that's going to give you the exterior angle of a regular polygon. Okay, well, let's put these into practice with these 3 questions down here. Okay, so it says find the sum of, okay, so we know we need how many sides it has, and it tells us right here this polygon has 16 sides. Okay, great. So the sum the sum is going to be the number of sides minus 2 times 180. So if it has 16 sides, then we know we're doing 14 times 180, which happens to be 2,520. Okay, that is a 16-sided figure. That's a lot of sides, so we've got a big number here. Okay, all right. Find the interior angle of an octagon. So let's use the formula for that. So to find an interior angle, we first got to find the sum. So we know it's the sum of an octagon, of all the angles of an octagon divided by n. But to get that sum, we have to go ahead and do 8 minus 2 times 180 and then divide by 8. So that's going to be 6 times 180 divided by 8. That's going to be 1080 divided by 8 and 135. So it's almost like two problems in one. First, we get the sum, so there's the sum right there, and then we have to divide by 8, okay? And it's 135 degrees each angle. All right, the last question is the exterior angle of a hexagon. Okay, that's 6 sides. So all we gotta do is 360 divided by 6, and that's gonna be 60 degrees. Oops. All right, guys. So let's move on to the next page. So basically, you have some figures here. And I just want to clarify the textbook practice is incorrect. This textbook practice should be page 454. Okay. So basically, the two questions I want to get answered here are: one, what is an interior angle? And 2, what is the exterior angle? Okay, I already did the triangle, so I'm not going to do that again. So I like to do this pentagon here. So first of all, an interior angle, we know we need to divide. So this is a pentagon, it has 5 sides. So let's go ahead and find the sum. So it's going to be 5 minus 2 times 180. That's going to be 540. And then we're going to take that 540 divided by 5. And that's going to give us 108. Okay. That means each angle here is 108. And now we want to find an exterior angle. So let's say this one right here. exterior angle is going to be 360 divided by 5. $72. Okay. And this makes sense because this is supplementary right here. These two, this makes a straight angle. So 72 plus 108, that's 180 right there. Okay, for this straight line. Alright guys, you'll be able to practice these on your own or in class. So we're going to move on to the next page. Okay, we finally reached our last worksheet for 8.2. And I hope that you were able to reorganize your workbook so that everything is in order. I believe it's 11 or 12 worksheets for chapter 8. So let's go ahead and take a look at similar polygons. Okay, so for example, these two rectangles are similar because they're both rectangles and one is bigger than the other, obviously, but we can create ratios, which in turn creates proportions, and this proportion we can use to solve for any missing side that we have. Okay, so the strategy here is to use ratios to make a proportion and then solve the proportion for any missing side. Okay, so for example, we're missing A, so we can set up proportions. Now there's there's quite a few ways to do this, so I'm going to try to put it in perspective here. So we can kind of look at this as the left. This is the number on the left, okay, just by looking at the diagram. But there's another number over here that's on the left, so I'm going to call this left 1 and left 2. And then this 10 is, let's say it's the bottom number, and that's bottom 1, and this is bottom 2. Okay, so you can actually do quite a few different arrangements, but I'm just going to show 2. All right, we could make a ratio of the left and the bottom, for example. And if I make a ratio of the left and the bottom, then basically I can do the left 1 over bottom 1 equals the left, as long as it matches, left on top, bottom on the bottom. Okay, so I can do it like that. Okay. Or I can go from shape to shape, and I can do let's say I want to line up the left number. So I'm going to put the left number on the left, left 1 over left 2. I can also do that as well. And this bottom 1 over bottom 2. Okay, those are just 2 examples of how I can set this up. So what does this look like for us? So let's start with the first one. The one we did was left, so that's A. That looks like a 9. A over 10. That's the left over the bottom. Left over the bottom. A over 10, 6 over 8. Okay? A over 10, sorry. 8 over 10, 6 over 8. That's one proportion I can solve. And then this other one over here is left over left. So basically I'm going to do left over this left, that's one ratio, bottom over this bottom. Okay, so that's going to look like a over 6 equals 10 over 8. So notice that these two proportions look totally different. Okay, but the technique to solve is actually called cross multiplying. So we use ratio to make a proportion, solve the proportion for any missing side, and the technique is cross multiply. And cross multiply, not multiply across, but to make a cross. So you're going to go from bottom left to top right, and bottom right to top left, like this. Okay, let's just keep it in the same direction. So even though these are different proportions, you're going to see that when we multiply those, like we're making a cross. So that's A times 8 is 8A. 6 times 10 is 60. Okay, if we go to the other one, it's the same thing. A times 8 is 8A. And 10 times 6 is 60. Okay, so notice that these are the same. So as long as you line them, if whatever you choose, as long as you line them up the same way in both cases, it's going to work. Okay, so if we finish this off, we're going to divide both sides by 8. And we're going to get 60 divided by 8 is 7.5. Okay? And of course, since these are the same thing, we're going to get the same results. Okay? Doesn't matter which way you do it, you're going to get the same thing. So, pick whatever you like. If you want to stay within, make the ratios within the shapes, that's fine. Or if you want to line them up shape to shape, that's also fine as well. Okay? Okay, so I'm going to do the next odd problem, and from now on I'm going to just stick to one method, and whatever I choose, that's what I'm going to write down. You're welcome to do it some other way. Okay, so this one's a little weird because it's not exactly lined up perfectly. So, but as you can see, that I can do 15. I can just work within this shape right here. So I can do this side to the side where you have the parallel symbol. So that's going to be, I can do 15 over 20 if I want. And then that means I got to do the same order. So I'm going to do the number that's not marked to the number that has the arrows. So I'm going to start here, and I'm going to go this way. Okay. And there's a couple ways you can do this. If you just straight up cross multiply, which is fine, then I'm going to get 60 on the left and 20A on the right. Or you could have reduced it to 15 over 20 and then just multiply both sides by 4. So that's just different ways to do it. I'm just going to continue the same pattern here, guys. That's going to be 3. Okay. All right, let's go to number 5. Now, number 5 is an example where everything looks perfect. So I can go from, I can stay within the shape, or I can just go from shape to shape. So I'll just do it differently this time. I'm gonna go from big to small. Let's just because I want to. So I'm gonna start with the 12 and I'm gonna go here. So that means I'm gonna start with the Y and go here. So I can make, so remember, this is one method out of many. So 12 over 8 equals Y over 5. Okay. So 60 equals 8Y. Whoops, I forgot to show what I just did. Divided by 8. And then 60 divided by 8 is 7.5. Okay. So it's kind of awkward to go in reverse, but that just shows you doesn't matter how you do it as long as you keep the same pattern in both ratios. Okay. All right, let's go to the next one. Okay. So don't get confused by all the numbers. We're trying to find x here. So I can do x over 8. Actually, no, let me do x on the bottom. So I'm going to do 8 over x. Which means I need to start with the number that's not marked near the arrows and go towards the arrows. So that's going to be like this. So it's going to be 20 over 12. Cross multiply. So it's 96 over 20x. Divide both sides by 20. So 96 divided by 20 is 4.8. All right, guys, we finally reached the end of 8.2. There's a lot of material. Like I said, it's 4 worksheets for worksheet 3, 4, 5, and 6. The assignment's not that long, actually. So your biggest assignment for this week are watching the 2 videos and completing completing the workbook. Okay, so we will work on some of these evens in class and look for 8.3 in the next video.